All right, let's multiply together some numbers that are written in scientific notation. Let's say we want to multiply together 3.5 times 10 to the negative third times 2 times 10 to the ninth. Now, one thing I realize when I'm saying all this is how much multiplying is going on. For instance, we have 3.5 times 10 to the negative third times 2 times 10 to the ninth. And the nice thing about multiplication is that order doesn't matter. So when I'm multiplying all four of these things together, I can multiply them in the way that they're listed, or I could take that 3.5 and multiply that by 2, and take that 10 to the negative third and multiply that by 10 to the ninth. When I do that, 3.5 times 2 is 7. And from our product of powers property, if we're multiplying together two powers with the same base, all we have to do is take those exponents and add them together. So we'll take negative 3 plus 9. Our answer is going to be 7 times 10 to the 6. So here's our solution, the product of two numbers written in scientific notation, and we're left with an answer that's also written in scientific notation. So if we want to speed up this process a little bit and think about what we just did in the last example, ultimately what we did is take these two numbers, the 1.4 and the 4, and we multiplied those two together first. So we're going to do 1.4 times 4. Then, in the next part, we're going to take the powers of 10 and multiply them together. So we'll have 10 to the 11th times 10 to the 9th. When we multiply together 1.4 times 4, what we're left with is 5.6. And when we're multiplying together powers of 10, the base stays 10, and all we have to do is add 11 plus 9 and come up with 20. So here's our solution in scientific notation. Right? Short answer on how to multiply these together: multiply these a's that are out in front and then add the powers. So let's try that one more time. If we want to multiply together 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15th. What we're going to do first is to multiply together the 6.5 times 8.7. Then take the 10 to the 12th times 10 to the negative 15th. When we do that, 6.5 times 8.7 is 56.55. When we multiply together those powers of 10, we keep the base the same and add the powers. 12 plus negative 15, that's the same as 12 minus 15, is negative 3. But the answer that we're left with is not a number that's written in scientific notation. That's because this 56.55 is not between 1 and 10. We need that to happen in order to write this as a number in scientific notation. So I'm going to take a closer look at just that. I'm going to leave it as 10 to the negative third at the end. Right? But that 56.55, if we were to write just that term in scientific notation, we would have to move the decimal one place, so 5.655. And that original number, 56, is it a big number or a small number? Well, it's bigger than 1. That makes it a big number. So we move the decimal one place, we should have a power of positive 1. Now, putting this line together, we have our number that's between 1 and 10, so that 5.655. And then we're going to multiply together 10 to the first times 10 to the negative third. So we keep the base the same, the base is going to be that 10, and add their powers. 1 plus negative 3 is the same as 1 minus 3, which is negative 2. Real quickly, comparing this answer that's written in scientific notation to the one that we tried to change, that 56.55 times 10 to the negative third. Take a look at what happened there. We needed to adjust our answer by moving the decimal one more place. So we made this number that's out in front, the 56, we made it smaller by moving the decimal one place. We needed one less place. Okay. Then what happened to the power? The power changed from -3 to -2. So we had to add 1 to the power. So when we needed one less place, we needed one more power. So let's take 7.8 times 10 to the negative fourth squared. Notice I say multiply because when we're squaring something, we are taking 7.8 times 10 to the negative fourth times itself. But we do have some properties that we can use as well because we have a product taken to a power, which means we're going to take each factor in the base, that's 7.8, and we're going to square it. And we're going to take that 10 to the negative fourth and square that too. When we do that, 7.8 squared is 60.84. And for 10 to the negative fourth squared, we have a power to a power, so we multiply those two powers together and get -8. When we look at our answer, it's not written in scientific notation yet because 60.84 is not between 1 and 10. So we need to move the decimal point right here. Ultimately, when we move the decimal point to right after the 6.084, we needed one less place. So we're going to need one more power. I'm going to add 1 to that power. And we'll get 10 to the -8 plus 1 is -7. And there we go.